So our next talk is going to be by Jason. It's another one of these capabilities. It's going to be for the storage tiering. He's got like 6 minutes. We'll see. No, maybe 10. We'll give him 10. I hope not.
All right. So we went over this in training, but we wanted to just also give a technology update about what we've been working on. So this is going to be the storage tiering. The idea being that on the left-hand side of the picture, we have all of the instruments, and we have automated ingest helping us get that data onboarded into iRODS. And the question is well, how do we wrap policy around that data once it has been onboarded, and what happens to it there? The second thing everybody wants to do is get data off of the fast things and the expensive disk and into somewhere else that makes more sense, economically, and then maybe tier that back out to tape or something like that. And so at that point, we can now wrap this capability around. How do we get to the slides? There we go. All right, we're back. So now we can wrap this capability around data movement the same way that we have using automated ingest. So if we take a look at this image right here, basically we have captured that storage tiering policy as a C++ rule engine plugin. So this is just something you can now download and install. It is versioned, and we can support it. And the great thing about this, I think, from a technology point of view, is it's all metadata driven. All we are doing is annotating the resources within your system with metadata that gives it an identity, that gives it policy, and the C++ rule engine plugin is the thing that reacts to that policy. So if we look at this example graphic here, on the left we have the orange resource hierarchy. We'll call that tier 0, or any index that you like. The one in the middle we'll call tier 1, and the one on the right we'll call tier 2. They don't have any identity until we have some policy that cares about that identity. So using metadata, we can tag any resource with a tier group name and then give it a position in that tier group as its unit. So the attribute is this is a tier, part of a tier group, the value is the name of that group, and the unit is the index. And then you can annotate any number of resources that you want with this metadata in order to get it to participate in that tier group. By default, the storage tiering plugin will just take the last time of access into account, and so that is another piece of metadata. So you can annotate that resource within that tier group with a tiering time, and just say 30 seconds or 30 years, it doesn't really matter. And at that point, the policy engine will kick in and start moving data for you. So we can keep track of how that data flows through the system based on simply that last time of access. Let's see, where are we at in the slides? So we talked about the access time, and then right here we can just annotate everything with metadata, and then that's how we create tier groups. The great thing is that all of these resources can participate in one or more tier groups, so effectively the data can flow through all of these storage resources in any direction that you want. If you want to remove a resource from the tier group, you simply just delete that tag. You want to add another one or another index, you can do the same thing. So we talked about adding time constraints. That's once again just a piece of metadata. Those can be immediately flipped and changed. 5 minutes? All right. Verification of the data migration. So, is my data safe after it's been moved? Well, first of which we can just trust the catalog. All right, it was replicated, we got no errors. That's fun. We can go a little farther and say we'll replicate the data, and then we'll go back out around through the RPC API and stat that file system remotely and make sure that data on disk is matching the size that it was previously. And since we're all here and we like data, the last of which is, of course, the checksum. So we can perform checksums front and back and make sure the data is safe at rest before we trim the previous replica. When you fetch that data back, we customarily restage that data back to the lowest index in that tier. Well, maybe that's not the best use case, because in certain examples, maybe our tier 0 was out by our instruments. So let's say we instead of having, the instruments be completely remote and simply a client, maybe it's actually tier 0. We get it into data management as quickly as possible, so inside the namespace, and then replicate it through the system. But if we're going to pull it back for analysis, we don't want it to go all the way back to the edge. We want it to just go where the analysis, tier where the analysis makes sense. And so we can tag that resource with a flag that says this is the minimum restage tier, so it doesn't go all the way back to the instrument or wherever that data may be coming from. Also, we can preserve replicas. When we're tiering data, we typically will trim the data from the previous tier. Well, we can simply flag a tier and say, please don't do that, because maybe in your use case, you're going to want that data to age out and go to archive, but we're just going to keep a replica here for analysis, and then if we want to delete that data or trim that replica, we can go ahead and do that ourselves. So we can turn that on or off with a flag as well. Now, this is where things get interesting. So everything in iRODS is query driven, and basically all of the computation for violating objects is also query driven. Well, we've pushed that out to the users as well. Those queries can be annotations on the resources themselves. Now your tiering policy is not just my data is too old. Now your tiering policy may be your data is of a certain age, but it's also of a certain project ID owned by a certain group of users, or anything else that you can put together with our general query language. So now you, as the data grid administrator, can annotate each resource with one or more queries that dictate what a violating data object is. Users can come along and just simply flip a flag and say, archive this data, then the data will move. Or, the data gets to be of a certain age, or, Professor XYZ, their data doesn't move at all because they get to use all of the fast stuff as long as they want, because whatever science they're doing is just particularly interesting. That is entirely up to you. So you can annotate these resources with one or more queries. And since iRODS supports the concept of what we call a specific query, which means you can capture a SQL statement in the catalog, we can also reference those. So if the general query language isn't sufficient, you can just go straight back to SQL and then inject those queries into the catalog and then annotate the resources with those particular queries as well. And the last thing that we have here is we can also limit limit the number of results of the query. If you are onboarding a lot of data, we can start throttling things to keep you from overwhelming the catalog and whatnot. So that just gives you a rate limiting factor there. And of course, very, very detailed logging. So as part of the plugin specific configuration, you can turn on a very specific logging, so you can have a manifest of everything that has been moved by the query or the tiering engine, if that's interesting to you. And of course, since everything is driven by metadata, we have externalized that as well. So if you happen to have your own controlled vocabulary or your own words that you want to use and you don't like our words, we have given you the ability to change those, and that is also part of the plugin specific configuration. So you can just go in there and use whatever language you wish. Does that make sense? And I think we're going to not do the demo this time. No? Okay. Are there any questions? I know that that's quick, but we're running behind, so we're going to try to get back on track. Steve.
Our first plant here.
Well, it's a good one for me. So Jason, the question is, how is this intended to work when you're also working in an environment where you have products that do automated storage tiering back at the hardware level? Is this really fundamentally just a logical tiering, or is there an intent to tie it into structural cost tiering?
So, from an iRODS point of view, a resource is a resource. So if whatever we would be working with that is already, say, an HSM, like HPSS, for instance, it's effectively just another resource to iRODS. So to us, we don't know that if it's tape or not. So this is entirely logically within the iRODS namespace.
Okay. Yeah, I was really thinking about from the standpoint of products that exist in the marketplace that actually can go from, say, very low-cost SAS disk all the way up to very high-speed, enterprise class flash type disk.
Okay.
It just really depends upon how you set up your storage resource then. Correct?
Yeah, it's all configured by metadata. So that's just, logically in your mind, what is the fast stuff and what is the slow stuff. And you have all of the indices, yeah. Right.
Yeah. One from Mani.
Hello. Thanks, Jason. I know like some of the requests also came from me. Thanks for implementing within very short period of time. But only the one thing that very useful for our use case at least is it works great, but we want to use our own transfer protocol because we have spent enough infrastructure and technology that speed up the transfer. Currently, it uses the TCP or UDP, whatever.
Right.
Do you know where the roadmap, it supports a plugin where we can use our own transfer protocol instead of using the iRODS protocol?
Yeah, right now, so when we're tiering out of, when we're moving the data, effectively, we're using the iRODS replication API. So we create a replica, and then we trim the other one. So in the future, we expect within the V5 API to effectively delegate all of that to the multi-part transfer in one way or another, and that does have pluggable transport built in. And so that's where we all get together around a table and start building a roadmap. So that's why we have a consortium.
Anybody else? All right. Let's thank our speaker.
All right. Thanks, everybody.